In this video, we're going to talk about multiplicity of zeros. So in other words, what happens if that zero occurs more than once? So what would this look like? Well, what would this look like in factored form? So for factored form, let's just say we have a polynomial f of x equals, let's go with 2x times x minus 2 times x plus 3 squared. So if we're going to do our interval test on here and figure out where's the graph positive or negative, you can just picture the graph. So remember, we're testing these intervals, and in case you didn't know, why are we testing the intervals? Well, we want to see when is this graph positive and when's it negative. In other words, when is it above the x-axis, when's it below, when's it above again, when's it below. So we're going to go ahead and do this. We're also going to graph it. Take a look at this. By the way, this one has a total of 1, 2, and then this one occurs twice, so 3, 4 zeros. So it's going to be a polynomial with the highest power of 4. But what's going to happen is we're going to have the same zero occur twice, and you can guess it's going to be the negative 3. So our zeros, let's start with our zeros. Those are going to be 0, 2, and negative 3. And I'm going to put those on the number line. And this is going to have negative 3, 0, and 2, just putting them in the numerical order there. And by the way, we say that this negative 3 has a multiplicity of 2, and we're going to take a look at what happens with this multiplicity. What happens if it has a multiplicity of 2? And just so you can, just so you know, this is an even multiplicity. We'll take a look at what happens with an odd multiplicity. So, which by the way, these all have multiplicity of 1, so these have odd multiplicity. So just testing these really quick. So for between or when x is less than negative 3, so we're testing to the left of that. So a number less than negative 3, f of negative 4, if we plug it in, you would get a negative, and the negative 4 minus 2 is negative, and the negative 4 plus 3 squared. Remember, a negative squared becomes positive. So what we're going to have is negative times a negative times a positive, because everything squared is going to become positive. So that's going to be negative times a positive is positive. So it's positive on that interval between negative 3 and 0. Let's try negative 1. Plugging in negative 1 here, that's going to be negative. Then plugging in there is going to be negative. And then plugging in there negative 1 plus 3, well, it doesn't matter because it's being squared, is going to be positive. So that's going to be positive again. All right, testing between 0 and 2. The number 1 is there. So we plug in a 1 here, that's going to be positive. And then 1 minus 2 is negative. And then remember, something squared is always going to be positive. So notice anytime it has an even multiplicity, it's going to end up, whatever number gets plugged in here is going to become positive. And we're going to take a look at what happens on this number line because of that. So we have a positive, positive, this one positive, negative, positive, so that's negative. So it's going to be negative on that interval. And then we need to test to the right of 2. So f of 3, that's a number to the right of 2. Plug that in, positive, positive, and then anything squared is positive. So that's going to be positive. And there you have it. So looking at this, let me just plot our zeros just like we did before. So negative 3 is right here. I'll put a red dot, meaning it's a 0 there. And then at 0, right on the origin, and then also at 2. So notice our graph is positive and then stays positive. Notice the sign didn't change there. When it has an even multiplicity, the sign won't change. If it was a negative at the 0, negative 3, because this is where the 0 is from, since it's a squared, an even multiplicity, it would still stay negative. Whatever the sign is will stay the same because it's squaring there. And so anyways, you can always just go through the number test. It's positive and then stays positive. So let's see what the graph looks like. It's going to be positive, meaning it's above the x-axis. And then it's not going to go through. Mine kind of went through, so let me redraw it. It's going to bounce off of it. So it's got to touch the 0, because it's technically 0 at negative 3. Right here, negative 3, that's technically a 0, right? So it's got to touch the x-axis there, but it's just going to bounce right off because it's going to keep the same sign. Then once it gets over to 0, it goes through, because now it becomes negative. It goes from positive to negative. And then after that, from negative to positive, so it's going to, at this 0, it's going to go ahead and go through. And it just stays positive till infinity. So let me just redraw the graph, kind of put it all in one motion so we can see it being nice. And that's what the graph would look like.